In 1960, EMD's plant outside Chicago was producing 5 locomotives a day. The facility covered 4 million square feet of production floor. 14,410 workers moved through it every shift, assembling locomotives under 200-ton overhead cranes that transferred each unit between stations like a factory built for giants. The plant sat in a small village called McCook, Illinois, but it used LaGrange as its mailing address because McCook did not have a post office, and because LaGrange had a ring to it that a town of 350 people could never quite earn on its own. On the gate, a sign read, "World's Largest Locomotive Builders." For 3 decades, that was not a boast. It was a balance sheet. EMD, the electromotive division of General Motors, had captured 85% of every diesel locomotive sold in the United States. It was a monopoly with a parking lot, not a company competing for market share, but a market so thoroughly owned that serious competition had stopped registering as a concern. The most formidable part of that monopoly was not the machinery, it was the infrastructure behind it. By 1951, EMD had trained more than 10,000 railroad employees at LaGrange and 65,000 more through its fleet of traveling instruction cars. If a roundhouse foreman needed a part, a manual, or a technician at 2 in the morning, he called EMD. Everyone else was a secondary option, and the railroads knew it. 3 companies tested that dominance and paid for it. Baldwin Locomotive Works had produced more than 70,000 locomotives across 150 years of American history. It closed its doors in 1956. Fairbanks Morse had spent years building diesel engines for United States Navy submarines, precision machinery for the most demanding service imaginable, and still could not translate that capability into a viable locomotive market. Gone by 1963. Lima Hamilton merged with Baldwin in a last-ditch consolidation and dissolved along with it. Every major challenger that tried to crack EMD's position walked into the same wall: thinner service networks, lower production scale, and reliability reputations that could not close the gap with what EMD had been building since the 1930s. There was one more challenger. The partnership between the American Locomotive Company, known as Alco, and General Electric had held roughly 26% of the domestic diesel market as late as 1946. Alco built the locomotive bodies and prime movers. General Electric supplied the electrical architecture, the marketing infrastructure, and the service network. On paper, it was the right combination. In practice, the partnership was losing ground year by year. Alco's locomotives ran rough and burned fuel visibly. Roundhouse foremen called them honorary steam locomotives, which was not intended as a compliment. The electrical systems General Electric supplied were increasingly outpaced by what EMD was engineering at LaGrange. In 1953, General Electric dissolved the partnership. The railroad industry drew the obvious conclusion. General Electric had accepted a secondary role, electrical component supplier, builder of small export units for overseas customers, nothing that would challenge the company with world's largest locomotive builders on its front gate. That reading was almost universally held. It was also completely wrong. Here are the verified numbers before we go further. EMD held between 80 and 85% of the American diesel locomotive market at its peak. Its McCook plant employed 14,410 workers, the single largest employer at any manufacturing site in Cook County, Illinois. 3 major challengers had been eliminated in the previous decade. The Alco and General Electric partnership, despite holding more than a quarter of the market in 1946, had failed to move EMD from its position. And General Electric, in the year it walked away from that partnership, was publicly classified as a components manufacturer, not a locomotive builder. What no one in the industry knew was that in the same year General Electric ended its partnership with Alco, it had already begun building the machine that would dismantle the EMD monopoly. It would need 7 years, and it would need to do it without being noticed. The decision General Electric made in 1953 was not to compete with EMD the way Baldwin and Alco had, directly, openly, and on the same terrain. Every company that had tried that approach was gone or going. The decision was to disappear long enough to build something that could not be competed with. General Electric purchased the rights to Cooper-Bessemer engine designs, a line of industrial diesels originally developed for heavy stationary power and marine applications. The engineering team in Erie, Pennsylvania, was given a specific mandate: rebuild these engines from the inside out into something capable of sustained high-speed freight service and keep rebuilding them until the failure data said stop. James C. Rhodes, the General Electric engineer put in charge of the Cooper-Bessemer modification program, described the task in internal records as a process of systematic refinement. Every weakness surfaced in testing became a design revision, and every revision went back onto the railroad before it was considered finished. That railroad was the ERIE. In September of 1954, a 4-unit locomotive quietly entered service on the Erie Railroad. It wore Erie Railroad colors, black and yellow. It was formally leased to the railroad under standard terms. To any outside observer, it was an experimental export unit, the kind of equipment a components manufacturer might field test before shipping overseas. It was designated Erie Railroad number 750A through D. GE owned every bolt of it. That locomotive spent the next 5 years accumulating over 1 million miles of operating data in road service. Component failures were logged and redesigned before the unit went back on the road. Electrical faults were traced to their source, not patched at the symptom. Thermal stress patterns accumulated across seasons and grades and load cycles that no laboratory could replicate. And the 4 Cooper-Bessemer power plants inside that locomotive were rebuilt and refined so many times that the engine GE eventually put into production shared only its basic concept with what had left the Erie factory in 1954. When GE's own engineers raised concerns about whether the Cooper-Bessemer architecture could handle American freight service, and whether the electrical systems could sustain the load demands of mountain operations, the test data answered them with specific numbers rather than engineering arguments. EMD's engineers, watching from a comfortable distance, saw an export experiment. They returned to their work in McCook. They were not wrong to be skeptical of GE's capabilities. They were wrong about what was being built. On the 26th of April, 1960, General Electric announced the U-25B for the domestic American market. The designation stood for Universal Series, 2,500 horsepower, BB wheel arrangement, 4 powered axles in 2 trucks. At launch, the locomotive outperformed every competitor on the market by 100 horsepower. That was the number the press releases led with. The number that mattered was buried in the maintenance specs. The U-25B's electronics used up to 60% fewer components than comparable EMD and Alco locomotives. Fewer components meant fewer failure points, shorter maintenance windows, and lower parts inventory requirements for every railroad that bought one. The carbody was pressurized, meaning the locomotive actively prevented dirt and debris from entering the engine compartment and electrical systems, rather than relying on maintenance crews to clean them out on a schedule. The cooling system was self-cleaning, and because the locomotive shared its basic electrical architecture with the 400 export units General Electric had been selling internationally since 1956, railroads accepting the U-25B were getting a design that had already been debugged in revenue service across multiple continents. It wasn't a new product, it was a proven product that had spent 6 years in disguise. In 1960, GE sold 0 of them. The railroad industry was in a recession, and no one was ordering new power regardless of who built it. The demonstrators sat. Some in the industry read this as confirmation that the U-25B was a niche experiment, the kind of thing a components manufacturer builds to feel relevant. In March of 1961, 4 U-25B demonstrators began a barnstorming tour of Western railroads. Union Pacific placed the first production order. Southern Pacific requested a modification, a lower nose for better forward sightlines, and GE built it within the year. By the end of 1962, sales were accelerating. By the close of U-25B production in 1966, 17 Class I railroads had put the locomotive into service. The mechanical superintendents who received the first units reported something that never appeared in any technical brochure. The U-25B maintenance manual was roughly half the thickness of the equivalent EMD documentation. One veteran roundhouse foreman, who had spent 2 decades working on EMD power, described opening the U-25B engine compartment for the first time as finding a room that had been organized by someone who expected it to be serviced by a tired man working fast. Everything accessible, nothing buried. GE had engineered the locomotive to be maintained under pressure, and the railroads noticed immediately. Between 1981 and 2002, GE averaged 622 new locomotives delivered per year across North America. EMD averaged 338. The company that had failed to sell a single unit in its first year on the domestic market was now outselling the monopolist nearly 2-to-1. In 1987, GE passed EMD as the #1 North American locomotive builder. That position has not changed since. EMD's own general manager put the failure plainly. Clifford Vaughan, a General Motors vice president who had spent 35 years in General Motors' car and truck divisions before being handed the locomotive business, said publicly that they had kind of sat there, maybe a little fat and sassy. They just did not react quickly enough. Vaughan had taken the position 3 months before that interview. He was already behind. EMD's failure was built into the same architecture that had made it dominant. For 3 decades, the company manufactured everything in-house: bodies, cabs, engines, generators, all of it under one roof in McCook. That vertical integration gave EMD its quality and its speed during the dieselization boom. When railroad deregulation contracted demand in the late 1970s, the same structure became a fixed cost burden that could not be shared. In 1 year, during the 1980s, EMD delivered 255 locomotives into a market where it had once shipped 4 times that number. The workforce numbers recorded what followed: 14,410 at peak, 4,269 when EMD ended American locomotive assembly and moved production to Canada in 1991, a loss of more than 10,000 jobs across a single decade. Jack Wheelyhan, who had spent 36 years at the plant and was a third-generation railroader, said publicly he could not bring himself to watch the demolition crews work. The sign that had read "World's Largest Locomotive Builders" came down. Plant 1, 4 million square feet where EMD had assembled the locomotives that replaced steam across the entire country, was torn down in 2000. Across the country in Schenectady, New York, the reckoning had come 30 years earlier. Alco, GE's old partner, whose electrical systems had supplied GE the practical education it later used to engineer the U-25B, shipped its last 2 domestic locomotives in January of 1969 and closed the Schenectady plant that year. 121 years of continuous locomotive production ended with a pair of switches bound for a short line in Ohio. The site was eventually cleared. It now holds a casino. In 2005, General Motors sold EMD, the company it had owned for 75 years, to private equity for terms it declined to disclose. Caterpillar's Progress Rail subsidiary acquired it 5 years later for $820 million. In 2019, Wabtec Corporation acquired GE's locomotive division for $11.1 billion, with $2.9 billion in cash to GE at closing. The arithmetic requires no commentary. One of the 4 Cooper-Bessemer power plants from the Erie test locomotive, presumed scrapped when the program ended, turned up decades later running an air compressor inside a factory in Mount Vernon, Ohio. It had been there for years before anyone connected it to railroad history. The American Society of Mechanical Engineers eventually declared it a historic mechanical engineering landmark. Every GEVO engine powering a GE Evolution Series locomotive today traces its direct lineage to that engine, the one GE tested in secret, wearing Erie Railroad paint in 1954. EMD wasn't beaten by a richer company or a faster one. It was beaten by a company that accepted 7 years of invisibility as the price of being right, then spent 30 more compounding that advantage while the monopoly it was targeting sat still. That locomotive is probably already running somewhere. Nobody knows whose paint it's wearing.